There it goes. So yeah, today I'm very excited. We're going to learn how to make our own function. So we've been using library functions. We've been using everything from the data science library, of course. Like that's key. They've given us a bunch of cool things to make tables and make graphs from those tables and stuff like that. But at the end of the day, somebody, like the nice people at Berkeley, they wrote a bunch of functions for us. We can make our own now. We're going to learn how to do that, all right? In addition to the other libraries we've been using, like the math library or module, right? Math library, the NumPy library to do sequencey things. But yeah, this is chapter 8 stuff, so please read chapter 8. Let's do it. I have a cool extended example as well towards the end. Maybe we won't get to that this time, though. Maybe on Wednesday. But here's what it looks like to make your own function. We know how to make our own variables right now. It'd be like, we say y equals 42, and that makes a box in memory that holds 42. So you can use a name, you can use a word to describe something else, right? You can use a word like y to describe something in memory. You can store stuff for later. You can also use a name like double, or y again, or f, to describe a computation. And that's all a function is. It's just a name that, instead of packaging like a value, packages a recipe for how to do something. So here's what it looks like to make your own function. This is a function called double. This is how you read it. You say def to mean like I'm defining a function now. And then you give what's called the signature of the function. This right here is called the signature. And it's essentially you pretending to call this function that you're about to make. It's like you're giving it a name. Like I'm calling this function double. It's meant to double something. And then in between parentheses, like you would give something when you call it, right? Because you're supposed to double the thing you're given in theory. It's meant to take something. You call that thing some name, like x. Because the goal eventually is for you to be able to say something like this. Double 42, or like double 5. Like you give it some value, and you need to talk about the thing that you were given. Because the whole point of having a function is I want to call it a million different times. I want to call it a bunch of different times on different values. I want to call it on 42. I want to call it on 5. And so it's not always the same thing that I'm going to get given when I'm calling my function. So we're going to use a variable name. I hope that makes sense. To get whatever we were given. And then optionally on the very first line, and you can have multiple lines as long as like they're within the triple quotes, you can give what's called a doc string, which is short for documentation string. It's essentially a string. It's a triple quoted string with either 3 single quotes or 3 double quotes, where you kind of like write a description of your function for people to have. This is what gets given back when you say the thing with the question mark. You remember that? You say double question mark, or like table.read table question mark inside of Jupyter. It goes and it reads the doc string. So if somebody made that for a function, that's what it gives back to you. It's like some quick little documentation that describes the thing. So that's optional. And then you give as many lines as you need to, you also are indenting, by the way. That's how Python knows, like, I'm doing this thing. This is part of this new function. You give a colon to mean, like, here's the beginning. And then you tab over. It kind of does it for you. And then as many lines as indented you give, that is your function. It's called the body of the function. So I'll call this, should I be dashing that as well? So you don't have to have just 2 lines. You can have a million lines. That's called the body of the function. Shouldn't use any arrows. This is the body. And it's just like what you think of it as, like, oh, this is the head. I guess this is the meat, the body right there, telling you what happens when I'm given some x. Somebody called double on some x value. What do I do with it? How do I give back an answer? Okay, that's kind of what it looks like. And then usually towards the end of your functions, especially in this class, you're going to want to give something back to the user. You're going to want to produce a value. And so that's what a return statement does for us. It returns back to the caller, whoever's asking us to do something right now, like somebody in Jupyter, like we said, double 42 or double 5, something like that. We need to give back an answer to the person who asked for it. And so return space, whatever you want, gives back that thing to the user. Okay, so that's kind of how that works. So in theory, that's all you need to know to make a function. And now let me kind of walk through what's going to happen when we say double 42. All right, so if somebody calls this, like on a different line in Jupyter somewhere, you say double 42, what will go on in Python land is for a split second, it jumps all the way up to this code right here. It jumps all the way up to the body of your function. It starts running the body, but it's going to set 42 into this x. That's how it knows, oh, I want to double 42, not some other value. Does that make a little bit of sense? That's what's going to go on. And so for a split second within the function call, there is an x variable. This is like a variable, and it's set to the 42. It's set to the thing that you gave. This is getting shoved right there, and it's running the body. And then it's computing then 2 times 42, which is 84. And then it gives that answer back. It's returning it to whoever called double. So wherever we said this, this is going to be replaced essentially with the value 84. Does that make a little bit of sense? Any questions about that? That's what it means to call a function. We're passing it something. And that's where our argument is, right? It's going up to there. It's going into this variable that takes the same place, and we're using that to do some computation, and we give back an answer with the word return. Okay? Likewise for double 5. When we call double 5, again, we jump up to the body of our function, and 5 is being set into x this time instead of like 42. It's like whatever we put there, whatever that argument was, it's going in that variable in the same slot. And it starts, so for a split second then, it's like x exists, and it holds 5 this time, and it's running the body with that in mind. It's computing 10, and then it's returning the value 10 to whoever asked for it, so us down here, and this gets replaced with the value 10, and we can use it in a bigger place. All right, that's kind of how functions get called. They jump to the bodies of their definitions. They return back an answer usually. You don't have to say return if you just want to like do something, like do some steps, produce an answer. But usually we want to return stuff in this class, like we can do math with the answers. Okay? Are there any questions about this slide? Do you see it? See the vision? So it is very, very powerful and very, very cool. And I don't know, I could type the double into Jupyter, but for fun, let's do a different version of that kind of function. Let us make a new file for today, because it's a new chapter. But I'll steal this stuff. I'll steal the start of the old one. All this stuff. We want it forever. Forever and always. So I'll make a new one. Paste that. And I'll call it Chapter 8. And in theory, this will run and be happy. We know that sometimes it's not. Yeah, nice. Cool. So, okay, let's make a new function. And instead of saying double, let's have it be, instead of doubling, let's quadruple something. So I'll say def. So like, let's pretend we have it, by the way. It's like, how do I want to use this function? That's a good way to like imagine what you need. It's like, I want to be able to run a function like this, quadruple, and give it like 42, and like it produces 42 times 4. Like that's how I want to use it. And so that will inform my definition. I can say like def, quadruple is its name, you give its name, def name, quadruple of some value. It could be y. We don't have to say x. It's just whatever you want to call the thing that you're given, you put it there in the same kind of slot as it would have gone when you called it. And then you give a colon, and then you hit enter to have a new line, and just by default, Jupyter tabs over because it knows like, oh, you're going to give a body of a function right now. All right. And then if you want to, this is optional, you can give a doc string to describe what your function does, so remind yourself later, or other people who use this thing. And you can use triple quotes, either double or single, as long as you're consistent. So like, what should this function do? It's supposed to quadruple the value of y, the thing that I was given. Okay, that's what it does. And then the way it works is it computes the value 4 times whatever y you got, and it returns it back to whoever called. Does that make sense? You see it? And then you do shift enter, and now it like knows about that definition. It's there, and so I can use it. Isn't that cool? And the whole point of these functions is that you can use them a bunch of times, but I guess before we get there, remember that the whole point of the doc string is that you could have said quadruple question mark, and then it's like it gives back that doc string. You could have multiple lines to it, but like that's describing what it does. And so like that works for other things too, like table.readTable question mark. A lot of nice people gave us some doc strings that we like, so we like to add them ourselves most of the time. And yeah, this function works. Like you give it some value here, give it an argument, it gets set into y, and like it runs this code, and it gives the answer back, whatever you got. And so we know that multiplication works on more than just integers, don't we? So we could have called quadruple in a bunch of different things. And that's the whole point of having a function. We can use it in a bunch of different places, in all the places that it would work. So quadruple on 3.14. 3.14 is going to go into y, and it's going to compute a float. Remember that word with decimal places? Surprisingly, you can multiply strings, quadruple, hi mom, and that's going to duplicate it. So it works on a bunch of different things. You can also do multiplication on stuff by arrays, right? Quadruple on arrays, make array of, I don't know, 4, 5, 6. And quadruple, like 4 times that, like this whole thing now. It's getting shoved into y. And what's 4 times the array, 4, 5, 6? Well, it's like you go through it all, it computes a bigger one, where each element is multiplied by 4. Okay? Any questions about that? Does that make enough sense? We have functions. It's just code that you can rerun a bunch of times. Yes?
So the array is just in the quadruple values of each array indices?
That's right, because the second you make an array and you start doing math with it, that's just part of the way these particular arrays work. If you give it, like this is the array itself, if you give it like times 2, it'll go through each element and do that same thing to it.
Oh.
Does that make sense? Which is different to, you could have given another array of the same size, like 2, 3, 4, and then it would go element-wise. It would do 4 times 2, 5 times 3, 6 times 4.
So if I want to do like a different element, if I want to do like 0 indices times like the third index, would I have to go like select each it, or?
You could have done it that way, yeah. It would be, this function wouldn't work anymore, is
Yeah.
kind of the answer. Yeah, you'd have to make a one that works just on arrays.
Oh.
Yeah. Because it wouldn't work the same for ints anymore. It's like there's no 0 thing of an int, right? Yeah, good question. Other questions? All right. One very important thing to remember is that this little variable, this y here, is just meant to hold on to, for a split second, is while the function's being called, the value that you were given. So the y is holding on to the 42 when we call it there. The y is holding on to the 3.14 when we call it there. But the second you're done with your computation and you return something, the entire memory of the function call goes away. So if I were to ask about the value y right now, I will get an error message. It'll say y is not defined because y only exists for the duration of the call. It's only a little helper, a little hand to hold on to something while the function's in use. Otherwise, y is not part of the outside. It's part of the inside of the function. Okay? It's called a local variable. So yeah, I think that's most of what I wanted to say about the quadruple function. Do you see how nice that is? You can give a name to a complicated computation, and that's easier to program with. Especially if you had a ton of lines, like you just want to do that once and then you can reuse it. That's the beauty. All right. So if we're okay, I have a bit of a question for us. Here is a function that I have called f. And I would like you guys to think about, I guess you guys can just discuss amongst yourselves, maybe please get into little groups, talk about your weekend, say hello. I'd like you to think about what this function might do. So it says def f of s, it takes something called s, and it runs 2 lines. There's no docstring. It says total equals the sum of s. So think about what things you can sum up. What does that mean? And then it returns this final answer here. It says np.round this thing with 2 as the second argument. So remember that np round is like does rounding to the nearest something number of decimal places, and that's 2 decimal places. So that's my hints to you. My question is, what does this function do in total? Like, what name should it maybe have, right? What things does it take? Does it work on everything? Integers, floats? Is there a special thing that it needs? Think about like what np dot stuff does. What value might it give back? And what do you think you should call it if you had this code? What's a good name? Much better than f. What's descriptive? Does that make sense? The question. So see if you can remember like what all these things mean. Like what kind of thing will this function take, and what will it do? All right, please discuss. And then we'll come back. In a couple minutes, once you've like, go look up these functions if you've forgotten them. That's the whole point of the internet. Yeah, I'll give you a couple minutes to at least ponder. And that's important to take some time to stop and think. What does np dot stuff do? Our people worked on a bunch of stuff. If you want, you can code it up, try it out. What kind of things will it take? Oops, what have I done?
No.
Hmm. I'm gonna cut my timer off before it gets too loud. Yeah, I tried. Does anybody have an idea for like a name for this function? Like, what does it do really? Do we see it? Do we try it? What are our thoughts? What kind of things can we sum? Like, what is sum meant to do? Like, that's the first secret, right? To unravel. Is it? What's that?
Addition or combine?
Yeah, it's going to combine. You wouldn't call sum on just one int, right? Like sum the value 1. It would be an array. Yeah, take a sequence of things that are summable. So I would, like, my mind would go to like a sequence of integers, a sequence of floats. Yeah, good. So I think that's what S is going to be, right? You're kind of forced, because if you're calling sum, S must be a sequence, probably of numbers. So you can sum them. I guess maybe you could sum strings. It would look a little weird. But then this kind of np.rounding stuff, that also screams I'm running on a sequence, right? mp.anything is going to run something on a sequence of things. So it's going to compute a bigger sequence or a weirder sequence using that kind of math that we were kind of doing in quadruple. And it's going to round everything in this resulting sequence to 2 decimal places. Do we see that? See how we're reading that? So that's how that will work. And then, like, what does this kind of division mean to us? Like, so it takes the values of S, it divides each of them, right? Because division by a single value, this will compute a single value, divides each of them by their totals. Like, let's say I had this sequence. Like, it was the array 1, 2, 3. I'll draw it like that. And the total would then be, if we summed everything, that would be 6, right? And so it's computing S divided by total times 100. So, like, it's going to give back a bigger sequence where it's like 1 over 6 times 100, 2 over 6 times 100, 3 over 6 times 100. What does that look like? It's like turning all these values into, I guess, the 100 kind of screams percentage, right? Especially division by total as well. Like, you're dividing by the whole amount, so you're computing percentages. So it's turning like each of these individual values into like percentage values based on like what things were actually in this array. Does that make a little bit of sense? You see it? So that's how you can, that's our detective work of the day. And so maybe a good name for this function would be like, and then it rounds it all to the nearest 2 decimal places so that you can see it in a pretty way. Maybe we should call this like percents. Make the percentage, convert this to percentages instead of like hard numbers. Something like that. Yeah? So I think that would make sense. And that's how we can think about it. Maybe instead of F, we'll call it percents. And let's kind of think about how we could use it. And now that we know what it does, maybe we can add a doc string. Oh no, it's messed up my indentation. It's hard to paste from PowerPoint. There it goes. So we can say, like, what does this function do? Well, it converts, now that we know, it converts the values in counts, or, sorry, in S, whatever S is, a sequence. We even call it something different. I call it counts, actually. Like, let's change its name now that we know, like, what it does. Like, these are the values. Like, I'm keeping track of a certain number of, like I'm counting things, maybe, certain values. Like, maybe we're keeping track of counts of things. I don't know. That makes more sense to want to take the percents of that. Converts the values and counts to percents out of the total. It's like if you're keeping track of like votes or something, votes for one candidate, another, like you're taking all the counts and producing percentages to see if there's a majority. Something like that. So that kind of makes a little bit of sense. So it's not S anymore. I'm calling it counts. So you can use a big long name. up there. So like that's the thing we got. It's got a name. I think that makes sense. Yeah, let's do that. Let's consider it that way. And I think that's what I wanted to say. So you got sum counts. There's also another way to do it if you have an array. There's also a dot sum. So counts dot sum would have worked here as well. Just to remind you of sequence stuff. But yeah, we've got a function now, percents. Let's call it on an array because it needs to be an array. So make an array out of like 20, 25, and 30. Maybe those are like the vote counts or something. It's like, oh, okay, apparently this one was 40%. This is 33 and a third, 26.66666 all repeated, rounded to the nearest 2 though to get 6, 7. Beautiful. So I think that's what I wanted to say about that. So that's how that function would work. Do we see it all? See how that's kind of useful to put in one place, like that, all that code? You can just keep on reusing it. So there's that one. We could go further. We could make this a more fancy function, and I think we should, just to kind of get some experience with how to do that. Do I want to do this yet? No. So let's expand on this function. Let me redefine it to be better. So sometimes you want more than 2 decimal places in your output. You want to be more precise. So let's not hard code 2 here. Let's add another option. Let's add another thing that you give to this function. It's called, when you call it, it's called an argument, but when you put it in a definition, it's called a parameter for some reason. So I'm going to add a parameter to the function. Let's call it like, how many decimal places do you want? Decimal places. And so instead of saying 2, it's like, give whatever we got here. Decimal places. That's a more generic function, I think. You could use that in more places. And so now if I redefined it like that, and I use this, I got to give a new thing here. I could say, you know what? Give me to 3 decimal places now. That's kind of cool. So this 3 value is getting shoved into decimal places, and it's using it to do its work. Does that make sense? So just another value. You can take that in your function. Though you cannot use the function in the old way anymore. You cannot call it. Once you say, oh, this is the function now, that's what percents is doing. Now I'm missing that second thing if I forget it. You see that? So I am missing it now. It's like I'm missing one positional argument, decimal places. Like you better have given that. There is, though, a way to get around it. There's a way to give a default value if you forget one or you didn't give it. And we've actually been using this with library things. I need to show you how it works now, finally. Here's the last piece of the puzzle for like making functions and having parameters, these values up here, the things that arguments get passed into. If you sometimes want the user of your function to not need to give a decimal places value, you can choose a value for them. That's called a default argument, all right, or a default parameter. You can put a little equals sign here and give whatever you want the default to be. So like equals 2. And now, if the user calls your function like this, it still puts the 3 into decimal places. It does not use the default. But if you forget something or you purposefully don't use that second argument, you don't put something into decimal places, it will take the 2 out for you and use that as a default. Isn't that cool? So now I can call it, if I redefine it like this, I can call it in those 2 ways. I can call it in this way and get the same answer, or I can now call it this way again and not get an error. So this is probably the most generic way of making this function, and it's kind of useful. I hope you see that. And you can still call it the other way. You still get the access to the other version. It's like if you give a value, it uses that one, but if you don't, it uses the default. Okay? Any questions about that? We've made some functions, made a fancier version, like we kept on making it better. This is called a default parameter. Give a value if you forget one. So you can call it in 2 different ways now. It's like a 1-argument function and a 2-argument function packaged together, which is quite nice, and that makes our life easier as a programmer. All right, well, if we are happy with that, I have the next topic. So now, this is now where we gain power, all right? So if you make a function and you have a table, because we're working with tables all day long as data scientists, you can take your function and call it on each value of like a column of your table. So you can update values very quickly and in a maybe very complicated way based on some weird logic that you wrote a lot of lines about in just a function. So that's beautiful. All right, so I want to teach you how to apply a function to columns of a table, potentially more than one, because like you could have a 2-argument function, like use this column for the first argument, use this column for the next argument. So let me section this off. applying functions to tables. Capital T, of course. Any questions about like functions in general before I go here though? Are you ready for it? All right, so yeah, let me show that to you. It's very cool, and again, you should always be looking, like you learn a new thing on tables, you should probably be looking at the documentation page. Don't just take my word for it. So there's a table.apply. You got a table, you can say .apply, and this is kind of how it works. You can apply a certain function name to a given column label, or potentially maybe multiple column labels, as many things as that function takes. All right, so you can use built-in functions like do average and stuff like that, but there's more where that came from. Okay, so yeah, so that's kind of where you want to go every time you learn something. Always remember that. But let me give you my version of all that. So let's see. Do I want to make a table manually? Yes, I think I do. So let's here's my silly table. I'll make a table of a few places where we maybe know about. So a table of places that we could go to in the world. So it's a table with some columns. Place name will be an array of, I don't know, we got Fresno as a place. Death Valley is a place. I'll do their, like the, what is it? Their elevation above sea level. Death Valley is a place. I promise I'm going somewhere with a Shaver Lake is a place that we could go. And then there's an elevation for each of those places. Let me just copy that for a split second. What is the elevation of each of these places? Elevation. Well, Fresno, I had to look all these up. Fresno is apparently at 308 feet above sea level. Not very much. Death Valley is below sea level, negative 282. And then Shaver Lake is a little over a mile up, so 5,627 apparently, wherever they measured it, feet above sea level. And so that's my places table. So maybe you got something like that. And you want to do some math, and the math that you want to do doesn't really work with negatives. Like, it doesn't make sense for you to want to use negatives for your values. So let's make a cut off any negative value function. That's the thing that you can do. Be like def cut off. Let's cut off at like 0. Don't let it be negative. Cut off at 0, whatever value we're given. Cut off at 0. How do we cut off a value at 0? Well, with what we know, there's a few different ways, but with what we know, we can use the maximum function. If you think about it long enough, like, all right, maximum of 0 and that value, whatever I was given, return that. Because if it was negative, the 0 would win, right? And if it was positive, the value itself would win. And you return whatever that was. You see it? So that would cut it off at 0 if it was below 0. Isn't that cool? It's like, that can be our function. I'm just going to skip the doc string because I'm lazy. And now I can use this. I'll be like, cut off at 0. If I call it on -5, I'm getting back 0. See it? That's quite nice. If I call it, I can show you a bunch of different calls by separating them with commas. So I'll do that for you. If I call it again with some other values, like if I call it on 0 itself, it would still state as like, what's the maximum of 0 and 0? It's 0. And if I give it something bigger, it will keep that thing. And then you can actually include the trailing comma, but that's what it looks like. So like, okay, this value is going to give back 0. This value is still going to give back 0. It's cutting off at 0. If it's 42, if it's bigger, it'll take that. You kind of see how that function's working? And now, like, that's useful for us. Let's use that now. Let's apply it to our table's elevation column. You see it? That's what we can do now. So you can say, it's going to look like this. You say table name.apply. You give the name of your function, like what is its name, so I can call it for you. And you give as many column labels as you need for arguments that function takes. All right, so the first argument is the function you want to apply, like cut off at 0. And then every argument after that is the table's column is the table column index or name, all right, to use as the input. Okay, so it's like this. We say, got a table called places. We say places.apply, please apply the cut off at 0 function to every column or to the elevation column. Use elevation as as the argument to each call, and then please run all those things. And what it does is it creates an array of answers, an array of all the answers that your function gave back, one for each column. So it does the 308, the -282 got cut off to 0, and then the 5,627 stays that as well. Does that make sense? How that's working? So that's really nice. You can kind of see the power there, I hope. And you can now, because it gives you back another array, you can make a column, a new column in your table, can't you? Because it gives you back just as many things as there were. So you can say, all right, take this result. Oops. I could have called this something, but I'm just going to use it in a bigger place. Be like, you know what, places, I want to add another column to you with another column called like cut off elevation. So I can use that somewhere else. And how do I compute that column? Just like there. Apply my function to the old elevation column, give me back an array of all the answers, and that's just as long as the table. It's perfect. So here's elevation, cut off elevation. It's only changed it for Death Valley. All right. So that's kind of neat, and like you can save that as another table. That's important to you, and you can do math with this now. Any questions about that? That's pretty nice, I think. And so yeah, it's kind of weird to want to say the name of a function without calling it. That's a little odd, but it kind of makes sense. Like that's the one I want you to call. Call it for me though. Call it for me all those values. At the end of the day, the name of the function is a value. Like you can pass it around places. If I said its name and didn't call it and press Shift Enter, it's just like, oh yeah, that is a function. I know that is a function. So it knows that it is capable of being called. And because of that, it's just essentially every function that you make is pretty much just a fancy variable name. You can pass it around to places just like you pass around other variables. You can use it in a bigger place. Here's a weird thing that you could do. You can be like, you know what? It was called this, but I actually want it to be called this. Like take this value, this function, and also call it cut, like as a shorter thing to type. That's allowed. That's kind of weird. And so now I can say cut on -5, and I'm still calling that other function. Isn't that cool? Give it a new name. So that's totally a thing. Yeah.
You can use both.
Now I can use both names. It's still the same. Cut off. And actually, if I say cut, enter, it remembers its original name, but that's where it really came from. But I can still use the old one. Isn't that cool? You have two options now. It's just like you're placing it here too. You're moving it in. It's not like it's getting rid of it. Yeah, good question. Other questions? That's pretty powerful, I think. And I think I have a good example to show that to you. Are there any questions about this? Any more questions before I go to that example? Or do I have a question for you first? Actually, I have a question for you first. I think it's useful to get you some practice. So let's see here. What's the best one to give you? Let me give you our most evolved function, this percents function. That's the coolest one we've made so far. Let me show that to you so that you can try, all right? What I'd like you to do, please, is try to make a function called calculate total. So this is going to be a function that takes two things. It's like we did this example before, right? Let's turn it into a function. Calculate total with a price and a tax rate, all right? So like given an original like subtotal price and a tax rate, give back the final total after taxes on top of the original price. Does that make sense? Like make that function so that you can call it like this and be like, calculate total, I can spell, calculate total on like, I don't know, $5.99 and the tax rate. Ooh, this is a great point. We have to make a choice right here. How do you want to give the tax rate? Do you want to give it as the final percentage, like do you want to give it as the actual percentage, like 8.75? Or do you want to give it as 0.0875, like the actual percentage converted, divided by 100? Which one do you want to call it with? Which one makes more sense? Which one's easier for the user if you give them this function? That's a subjective answer. There's no right answer. But maybe to force you to do extra work, let's have it be called like this. So you have to do the conversion and do the math based on that. I think that would be more fun. So let's say that is how it gets called. And then your job is to give back like 5.99, take 8.75% of it, and add that back into 5.99. Yeah, there's your final price. I have no idea what the answer is going to be. We'll figure that out together. All right. It's like 5.99 times 0.0875 plus, I don't know, plus 5.99 again. Whatever that is. I think that'll be the answer, right? So, and then maybe you need to round it. You can have some fun. So please try that. I'll give you a few minutes, and please ask me questions as you're trying it. If you have any questions that come up, if things get confusing, I want to help. I think that's what I want to say. Question first.
Are we applying the percents function directly, or are we looking at something similar to plus?
Yeah, you don't have to. This is just an example of how to make a function. You're not actually going to use the percents function because this only works on individual numbers. It's not working on arrays.
Oh.
Does that make sense? Yeah, so this is just like reminding you how to define a function. Don't use that. It's not part of the answer. It's just like a template. Make a calculate total function that takes essentially two numbers, two floats, they're usually going to have decimals, and returns back a third float of the answer, right? Yeah. So please try that and see if you can do it. And ask me questions as you're trying. I'll give you let's say, a 3 or 4 minute head start, and I'll do it too. The very first line you're going to say is def, calculate total, and then you give the values of your parameters. Like, what do you want them to be called when you give them? You can just reuse price and tax rate. P and T, but it's almost easy. And so if you had a table then of like prices and maybe the tax rate's always the same, I don't know, you could have fun and calculate a bunch of totals all at once. And your last line will have the word return on it. So you say return, and then whatever you want to give back. And you can use little helper variables. Is it working? I'll give you another minute before I show you my answer. Do yell at me if you have any questions, though. Like you want to perform this computation, but with the things you were given, don't just like hard code it. It's like you're going to be using the variable names of your arguments. Why so loud? Was that enough time to think about it? Did any questions come up as we were trying it before I give away the answer, or one potential answer? All right, let's see. Let's see how I want to think about this. So I will say it's going to be def, right? I'll just call it calculate total. Calculate total with price and tax rate. Those are the things I'm given. It's like I want to use it like that. want to use it like that. It's always useful, so I'll give it eventually a body. It's always useful to think about, like, how am I going to use this function? I want to call it like this: calculate total with some price, like $7.99, and some tax rate, I don't know, 8.975, like whatever it was. It does not have to be the same each time. We're going to keep on reusing it. Let's figure this out. So I've got a price, I've got a tax rate, and I want to do this kind of computation, right? I want to take the original price and multiply it by the tax rate, having converted the tax rate to actual percentages, and then add back in the price. Alternatively, I could have multiplied it by 1.0875. That would also work as well. So either way you want to think about it, but like that's the answer I want to give back. I want to take the price and multiply it not by the tax rate originally, but the tax rate having first like divided that by 100, right? Giving it back to like mathematical percentages. So do that. So now I've got price times the 0.0875 or something. You see that? And then once you have that answer, just like the order of operations will work out here. It's like add that back into the price. It's like it'll do the multiplication first. Order of operations for the win. And like that's my final answer. Does that kind of make sense? Is that how we did it? How we thought about it? You could also have done like 1 plus the tax rate divided by 100%. That could also have done it. But this is my final answer. I need to also remember to give it back. Like I'm doing the work and I need to give it back to whoever called me. That's what return does. If you forget that, it just like it gives nothing back at all, which is probably not what you want. So I think that's the one. And then you could use it in a bunch of different ways. $7.99, you could call it on $5.99, 8.75. The whole point of having a function is that you can reuse it. It's code that you can reuse. This doesn't really look like dollar amounts because it's not rounded. So maybe that's the last piece of the puzzle. You could have said round. It's like, does that exist right now? Do I have to include the math library? No, it's built in. Cool. Take the, like, okay, my final result, and maybe this is getting a little too long for this line. You can say like, all right, my answer is, dun dun dun. Here's the actual price result. That's my result, but actually I want to round that result to 2 decimal places. Does that kind of make sense how I'm doing that? I could have done it all in one line, but it's useful to use an extra little variable there. So that's also kind of nice. So now if I use this function, the answer I'm getting back is rounded to actual cent values. So maybe that's a better answer. I don't know. Any questions about how I came up with that? Does it make enough sense? It's kind of cool, kind of useful. So yeah, imagine you had a table of things. Again, you could apply this to that table and come up with some values very quickly, do some math very quickly, and your boss would love you. So yeah, I think that's what I wanted to say there. Now I'm ready for a cooler example involving functions. Are we ready? Ready to make a very fancy function together? All right, so what I would like to do is predict values, like look into a crystal ball and predict values. So what we want here, all right, is there's a cool little data set that our textbook people have given to us. It's measured a bunch of heights of parents, mother and father, and then the height of the child of that parent, of those 2 parents. So what we're going to do is we're going to take that table and we're going to predict stuff. So if you would like to follow along yourself, it's in our data folder in the Coach Room class. It's called Family Heights. It's this one. So I'm going to read that in. We're going to use some of those things. So I'm going to say this is prediction. So this is going to look really cool once you get it working. So we're going to use some graphs. We're going to practice everything we know with this example. I think it's a good example. So, all right. It's called table.readTable. I want in my data folder, it's called Family Heights.csv. And I'll call that, I don't know, Family Heights equals that. And for some odd reason, let's see here. I will deal with that eventually. Do I want to deal with that right now? Give me 1 second. I guess I could. No, I'd rather keep them all. There's something that I could have done that the Berkeley people did, but I will not do it, I don't think. So let's call that Family Heights. And this is what the table looks like. You got family number, and then this is like in inches, the height of the father, the height of the mother, and we've got, let's see, the height of or how many children they had, child number each of them, like I guess in order from like oldest to youngest. and then the height of those childs as well as like their gender. So that's kind of cool. Mid-parent means the average of the father and mother, and actually I'd like us to calculate that. So I am going to get rid of that, actually. I think that's a better way to think about it. Like I want to give us practice. Like mid-parent, let me just like, let's forget about what that means. I'll say drop. It was 0, 1, 2. Column number 3, go away, please. That's family heights now. It does not have mid-parent. We're going to calculate that ourselves. So this is what it looks like. And what we will do is we would like to predict the height of a child given the heights of their parents. We have a bunch of height values, right? We have a bunch of father heights, mother heights, and child heights. There will be a pattern here. We could graph that pattern, and I kind of want us to notice that first, maybe. So let's get there. So instead of father and mother separately and considering them separately, and you could do that to do your prediction, let's consider them as a unit. Let's take the average father height and mother height, okay? So those are we'll call those like parent averages. And the way that we can compute that is we take the father column and the mother column, those values. So it's family heights dot column, give me the father column, all those values as an array. Also give me the mother column. I want to add them up. And I want to divide, all right, by 2. And so we got to do it in this order. Do you see how that's going to create a bigger, or another array, here in averages? Going to create another array that holds the average height of each of those parents. So let's just add them up, divide by 2. And so we got all these values. They look a little weird, but that's useful for us, okay? That's those. And so that's my array. I have that as many things as there was in the table, as many children as there were. So I can add that back into the table now. I can make a new table even. I can make a table dot, start with a blank table, add some columns, including parent averages. Columns, let's do parent average. And we'll do, like that's coming from parent averages. And then we also want the height of the child for each of those parents, all right, for that parent average. So what's the child height? It was whatever was also in that column, right? So it's just like take the child height of the original table, all right? So I'm computing the average. I've done the computation of the average father and mother height, and like I want to pair that with their child heights now, all right? So that's what I'm going to do. So I'll take child as the child height column from the original table. So it's family heights dot column child height. The capital H for some reason. That's my table that I want to compute. And so that's a bit cleaner, right? It's like 72.75 is apparently the average of 78.5 and 67, and the height of that child was 73.2. I'm just pairing that right there. And these are all from the same family, so this is all 72.75, and there are their child heights. Okay? So it makes sense what I just did. I've given like one value now per parent. Like I've combined the parents in a way. And I'll call this table, let's call those heights. Those are the heights I care about. And so we can explore this table, of course, with stuff that we know how to do. There will be a bit of a pattern in theory, like taller parents are going to produce taller children on average, right? Something like that. So we can make a little scatter plot and be like heights dot scatter. On the x-axis, let's have the parent height average. You can kind of see that there's a bit of a trend, right? It's like it is a little clumped together, but like on average, like it's kind of moving that way, but not a lot. A little bit though. So that's kind of cool. Here's what we're going to do with this data now. Here's the cool thing, all right? Here's the key idea that's going to produce a nice, interesting function for us to study. And this is what people do. So let's say that somebody gives us a height. Like, all right, the average mother and father height for this imaginary family, or for my family, is this. Please use the data that we have to predict how tall I might be, right? For somebody like, or somebody has a child, you know their heights, but you don't know how tall the child is going to be. You can use their averages to create a prediction, all right? So use the data that we have for similar parent heights, like maybe like you say that the average height of these parents is like 72. So like go look at the heights for all the parents, like for all the children whose parents were like 71 to 73 or something, squished between 72, like figure that out, something like that. So what we'll do is we'll take the average over nearby parent height. So like if you said, my parent average height is 68, what we will do is look at all of these points. Does that make sense? All the ones that are a little less than 68, a little long, like wrapped around 68 from like 67 to 69, and look at all these points. And like those are examples of people and their children and their heights. And then we could take the average. And like that's a decent prediction, right? Somewhere in the middle of all of that is probably where your child is going to be, given what I've seen. Does that make enough sense? That's one way to do it, and that's kind of cool. So let's say that we've got the number 66. 66 was like the height of two parents that come into the doctor's office one day that are having a child. So let's go and find all of the values in this table that are close to 66. Close to 66 will be all of the rows in the table, all the heights stuff, like all the rows in the heights table where the parent average, because that's what's in this table, right? It's like parent average and child height. Where the parent average values, there's a cute one here. It's perfect for us. There's it's like where the parent average values are like not above, not below. There's one called between. Where the parent height values are between, let's do like, I don't know, 65.5 and 66.5. You see how that's going to wrap around the number 66? Like you can choose the range that you want, but like that's a range. You can do it bigger, so I can go from 65 to 67 if you wanted to. I encourage you to try that, by the way. So like those are going to be some values that are close to 66, like wrapped around it. Let's see what we get for that. Close to 66. So here's a bunch of parent averages and childs that are around there. And like look at all their children. And I think a good prediction of the height of that child, that like, all right, the parents come in, like their average height is 66 inches, will be the average of the child heights that I know about for those other parents with similar average heights. All right, I said the word average way too many times there, but I hope you get it. It's like here are these parents and children, I guess they're adult heights, that are close to 66. Let's take the average of these child heights now, and that's a good prediction. All right, or at least you can do a lot of stuff right now and be like, all right, just get that column first of all, close to 66. Give me that column called child now. Give me all those children heights. And now you can calculate, all right, a max and min value as well. Like, all right, the smallest height of a child that I've seen for parents whose average height is 66 is like 57.5. So maybe your child's going to be no smaller than that. Something like that. No shorter than that. You can do like min max. I'll put commas to separate these values here. Min max, like there's the range that your child might be in. From the data that I've seen, that's how small and how tall children are whose parents are around 66 inches on average. And then you can take the average of all of these as well. Be like, give me that child column, and you can do np.average to go and take the average of everything there. Dun, dun, dun. And it looks like it's a little bit taller than 66. So I guess that's to be expected, which kind of makes sense. Are there any questions about what I've just done? I haven't made a function yet, but like this is how I want to think about the data. Like if somebody gives me a parent average height, like I want to predict something like that. You see the point of it? Like why you might want to do that? Why it might be close to a good idea. So let's make a function now that does that. All right. It's like you give me a height, I'll do a prediction for you. All right. So let me call that to you. All right, let me make that and show it to you. So it's essentially we want to take what we did here, but like make it generic. All right, don't like hard code 66 everywhere. So let's do that. So I want to say def predict child. You give me the average of some parent heights. You give me a parent average height. I'll call that p average. I want to then go and find all the points in my existing data in my heights table. It's called heights still, right? Heights. That are close to that value that you gave me. Maybe it was 66, but maybe it was something else. All right. So that's the first step. I want to find all the close points. So let's go through that table. It's kind of this process all over again. I'll call those close points. Take the heights values where the parent average is close to this p average. So where it's between, like, I don't know, it minus 0.5, because that's what we did for 66, right? We've calculated 65.5 and 66.5. So go from there to plus 0.5. Do you see how I'm making that more generic now? It will work for any value that I'm given now. See that? That'll find the close points around that value, whatever it was. And then what I want to do is taking those values, taking those close points, compute the average, and that's a good approximation of how tall that child's going to be. So it's called close points now. And like that's an answer. That's a prediction. Does that make sense? That's pretty cool. So now, like, we have packaged this idea of the prediction, and it will work for any height that we could give. So predict child of 66 will give back this exact value. It's just we've packaged together that computation. Now it'll work for other heights. Predict child of, like, if the parent average was 70, it was a bit taller, but I guess on average the heights go, maybe that's too tall. I don't know. They go back down. There's a regression towards the mean, or as statisticians would say. So now I have this. This is really cool. I have parent averages, I have the actual child heights, but I can also now produce a prediction for each of these parent averages as well and see how they compare with the actual children. Isn't that cool? So let's do that. We can add a new column, like we can apply our function to parent average. You see it? We can apply it. So it's called heights dot apply predict child, please, to the column called parent average. So for each of those parent averages, go and predict, please. It's going to take a while because, like, it has to do some thought processes. The first 4 parents were the same. So that's the prediction for each of those children, how tall they will be, something like that. And we can make a new table based on that. Like, we can take the existing one, heights, add a new column that contains that. It's like prediction is those values, and we can call this a new table and call it like heights with predictions, which is pretty cool. Yeah, there's a lot of scrolling to do there, and let's just take a look at that, and we'll just have it computed once and for all. So that's what I've done. I've applied my function to the parent average column of each of these rows. So for this one, apparently the prediction is that. See how it compares to the child. Apparently, again, it's still the same prediction because it's the same parent average. Like, these are the same parents. And this one is that. It compares in a certain way. Isn't that cool? Questions about that so far? Because now we can graph that. And that'll look very interesting. All right, this is leading us to somewhere we're going to be going very soon in the class. So now I have this heights with predictions table. I can do a scatter plot of that, again with the parent average on the x. But look at what happens. Because now I have a child and a prediction values, it's going to graph both with different colors. Boop. So we're kind of seeing, it's kind of drawing the trend for us, if that makes sense. See what it's doing? So, like, for each parent average, like, here was the actual child height for those parents. Like, there's a range, of course. But, like, here's the average of those values. Here's the average of all the nearby values. Like, this is what we're predicting. This is what we're predicting. And so I guess, on average, tall is not very common. Even if you have tall parents, like, a lot of their children come back down and be shorter, which is interesting to think about in itself. But that's a very cool graph that we just made. Does it make sense how we made it? This entire process of doing this kind of prediction, we made a function to do the prediction for us, find the close values, take the average of those close values. That's a way to predict the future potentially, given what we know. And, like, that's the job of a data scientist. I love it. Question?
That's a silly question.
Yeah.
Can you change the colors of the graph?
You can. It has to do with the style thing at the top here. So I don't know what the other styles are. This is the style that your textbook uses for the entirety of the textbook. I don't know what other options there are, but you can look into that. It's called Matplotlib PyPlot style. There are other baked-in styles, and I think you can probably make your own by giving a bunch of different colors in an order. But that's where that comes from. Yeah, I think they chose that one specifically probably because the first 2 colors are Berkeley colors. Yeah. Which is funny. Yeah, I think it's more or less what I want to say. Other questions about this example? Kind of neat, I think. Kind of neat. So functions can get you pretty far. And then we can just keep going further. So are we good for another topic? we'll of course come back to functions soon, but I want to show you some things that I've already done technically last time, just like I glossed over them. I finally want to explain them now that we have functions under our belt, because like functions are important here. So there's something called .group on tables, which I did show you, and it groups values according to something, according to them being the same. So here, let me show that to you. You got a table and you do .group on that table. So it's this one, .group. Advanced table functions. What it does is by default you give your name of your table, you give .group, and then you give the name of a column, and then what it will do is usually that column is most likely a categorical variable, like it's a color, it's a station name or something, and it's going to go in by default. It's going to count up all the different times you see that particular value of that column in your table, which is useful. So let me show that to you. And that's the default. Default's to counting, but you can change what it does. It can potentially take a second argument that is an arbitrary function that maybe you could make that combines the values in a certain way. Okay, so that's where I want to go. Dun, dun, dun. How do I want to do this? Yes. I'll make a new section for sure. Grouping, and let's go back to basic things. Let's use our like ice cream cones data set. Nice and small, nice and easy. Table, read table, data. So that is called cones.csv. So here's my ice cream cones table with flavors and colors and prices. So I've got some categorical variables here. Okay, and so let's say cones.group on the flavor. And so what it's going to do before I show it to you, what it's going to do is it's going to take and find all the different flavors. You got apparently vanilla, chocolate, and strawberry, and bubblegum. You got all these different flavors, 4 of them, and it's going to, by default, count each time they appear. Like how many vanillas are there? How many chocolates are there? Stuff like that. And you'll get it like this, all right? And I guess by default, it sorts it in that way, in alphabetical order of the column that you're grouping on. So it's like bubblegum, there's one of those. There were 3 chocolates, 2 strawberries, 1 vanilla. Okay? Does that make a little bit of sense what it's doing? It's grouping them all and by default counting every value in that group, in each of the groups. That's useful. That's useful to want. It helps you build cool graphs. I used that before. We needed it for some interesting questions that you guys had, but now you can kind of see it better. So that's the first thing. Question first, yeah.
.group automatically makes the column count.
Yes, it makes a brand new table. Essentially, it takes all the unique values of the column you give of the original table, so all the unique values of the flavor column, and that's one column, and then it adds its own little count. It makes a brand new table with a count column as well for the counts of each of those values.
So it's a table of a table.
Yes, you start with a table and it makes another table for you. Yeah, so this makes a brand new table for you that you can go look through and do stuff with and graph after that, which is cool. Like we were using that for graphing before. Other questions? That's what .group does by default. By default, it counts them up. But really, secretly, what's happening is there's a default parameter going on there. You can take, really, it takes 2 things. You say table name .group. Really, what I should say is this. I don't want to teach you about lists yet. Defaults to counting, because what it does, essentially, is it takes all the values. It takes, like, essentially computes chocolate, 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 and like it creates like an array, essentially, of all the values that are there. Give me an array of all those values, please. And by default, it like gets the length of that array that it's making of all those chocolates, all of those bubble gums. It gets the length of them. So that's essentially the same. That's what it is doing by default. So I could have said cones.group flavor, and how do I want you to group all the values? Once you've grouped them, run len on all of them to get the length of all the sizes of those groups. Essentially is what it's doing. And that's like it's counting each of those, more or less. And so these are no different because it has color and price. Those are the other things. It's like how many times I see a length, a bubblegum color, a bubblegum price. Well, there's one of each. It's counting things. So maybe that's not the best thing to show you just yet. But like that's what it does, more or less. All right. So the second argument that you give is how you combine the other values, more or less. How you combine the other values in your table. So like this is the default, more or less. It also like squishes values, but like that's something that you could do. So in theory, here's another idea. Flavor. What else do we have? Let's do the averages, because like the other things that we have are like after flavor, after we group by flavor, we've got colors and prices. Let's do the way it works again is it takes all the values of the bubble gum and the chocolate and the strawberry, it brings together their things as like an array, all of their values, all of the chocolate values as an array, and you could run a function on each of those combined things, on all those arrays that it's making of just chocolate, of just strawberry. And one function that you could want to run on an array of a bunch of things of a certain type is like average. So let me kind of show you what this is doing here. So here's the cones table, right? Remember the cones table looks like this. Flavor, color, price. We've grouped by flavor. So you got those 4 different flavors. What it did is it put all the values for each of the columns as an array. And it tried to take the average. So it made no sense for color. So those are blank now. It's like, what is the average of pink? What is the average of light brown and dark brown and dark brown? It made no sense. So it just like defaults to nothingness when it can't figure out how to average something. But for the price values, it knew how to do that. It could figure that out. So what it did was for every chocolate cone, it made an array of all the different prices for the chocolate cones only. And then it applied this function to that array to produce that value. Does that make a little bit of sense? That's what it's doing. So just the chocolate flavors, what was the average price of them? Just the strawberry flavors, what was the average price of them? That's a little nice, right? That's pretty powerful. And so like essentially that's what Len was doing, was like taking the length of those arrays, which is always going to be the same. So that's why that's the default. But that's pretty cool. What else could we do here? You can do like, give me all the values, make an array of them for me. Like that's a thing. Cones.group by flavor and call make array on each of the arrays of things. Oh shoot. Never mind. I guess I do have to use list here. Darn. It's because of the strings, probably. I guess I do have to say list here. I don't want to say this too much right now, but the word list, think of it like more or less the same as make array. Mostly the same as make array. I'll talk more about lists later, and I think your assignments in book will as well. But essentially, the idea of a list is still a sequence, but it's a little less cool than arrays. But like you can bring them all together. Like this is what it's making. Like it's making these sequences. Like here's all the chocolate values for color. Here's all the chocolate values for price. That's what it's doing under the hood, and then it's applying functions to those sequences. And like list just like gives you back the sequence itself. Here's a cool thing that we could do. We could do let's get the most, like we're a big spender today. Let's, for each flavor, get the most expensive cone of that flavor. Let's try that. So I can say, again, cones.group flavor, and instead of doing it by, like, give me the list, give me the sum of all the values in the flavor column, like here's the total prices. What we can do is we can get the max. Get the sum of the values if you want. We can call max on each of those. Like for each flavor combo, give me the max. So apparently the maximum chocolate cone price is $5.25. Same for strawberry. So it's going and it's picking out the maximum value. Max for strings also works, but it's a little weird. So let's not deal with that. You can before you do the grouping or after, honestly, you can drop a column, be like cones.drop the color column. I don't want you to group based on that or like do any answers based on the color. Just group the flavor and the prices, please. So that's what you can do in that way. So like here is for each flavor of my cones, what is the maximum price that I can get? I group by flavor, and then the way that I'm aggregating the data is given all the things for chocolate, all the things for strawberry, all the things for vanilla, call max on those things. Give me the maximum one only, please. Okay? And any questions about that? It's a very powerful thing. It's a little subtle in how you need to use it, but I hope you see how cool it could be. Is there a question? Yeah.
For the max, just thinking like whatever like the most expensive price was of that day. Or...
Yeah. So what it's doing again, let's go back to this example. It's a great example. So essentially, what it did for chocolate is it produced this sequence. It's finding all the values for chocolate, their prices, and it's calling max on that.
Oh, it's like max on the array of combinations.
Yeah, for it's separating everything by the flavor. That's the point of grouping, and then it's doing something to all the values of that particular flavor. Now, after
So basically, what we did to the first one with average, we did it again with the average to max. Okay.
yeah. So instead of taking the average price of all these that I see and computing that, then I'm taking the maximum price instead. That's another way to get my data and do stuff with it, to aggregate it in a way that I care about. Yeah. Nice. So I think I want to show you guys, or let you guys try now. Try to take the, I don't know, let's do Pokemon. I think that would be fun. Go and get the Pokemon table and find the average HP, like that's how strong they are, right? How many hits they can endure. Find the average HP for Pokemon grouped by their type, which is called type 1, their primary type, like electric, fire, water. So see if some Pokemon are stronger, more like they can withstand more hits. Their hit points on average is bigger. And try to, if you get that done, try to plot it. Like that's one nice thing to use a grouping for. Like it's a way to make a graph that you didn't have the ability to make before. So try to import that, read that table. It's Pokemon.csv, right? Try to get that, drag it in wherever you are. You have it. Try to group the Pokemon by their primary type and get the HP average. You're going to group and do an average, something like this example. And then see if, because that will produce a table. Oops, I don't want it there. I would like it to go here. Oops. Oh no, I've copied the actual. Okay, let me fix all this. There it is. Okay, so I want this. Do that. Do that. There we go. Okay. And this will produce a table, and then you could try to plot that as well. What would be a good way? Think about it. Could be a. Well, I won't give you any hints. Go look at the documentation. So I'll give you a few minutes to try this and play around. And please ask me questions as you're trying it. Give you a 4-minute head start again. All right, many steps. Read the table, do some grouping, which will produce a table. You'll have to save it potentially if you want to use it for multiple things, and try to make a graph of what you got in some way that makes sense for the data. There's only some kinds of graphs that make sense. For example, like a line plot. There's no chronology, so there's no use to make one of those.
They don't drop all the other ones and just do the name and the type.
Right.
Would I just dot select? Or would it be?
Yeah, select would be much easier.
You don't have to drop every single
Yeah, otherwise you have to drop everything.
So I have to select two things then?
So you say Pokemon.select. I want to select the name and the type 1.
Okay.
Something like that.
And you add dot group to after you select it, or then you get separate one.
Yeah, because every time you do something to a table, like those functions, they produce a new table. They'll give you stuff on top of it. Exactly. And if you're not feeling Pokemon, like you know that we have other data sets, so go try the Titanic one. But I want you to try to group not by the default, by something else. I think this was a good idea.
Was that the average of both the type and the name?
Yeah.
I want to just take the average of just.
Oh, I'm sorry, we forgot something, because you want to deal with the HP values. That's what you really want the average of.
Oh.
You want to group by the type, but it wasn't name, I'm sorry. Because we always use name, that's why I got confused. But we don't care about the name anymore for this particular question. because you're grouping them all. You don't have anybody specifically need it. Another 30 seconds before my timer goes off, and I'll show you my thoughts. All right. Any last questions that came up that I can answer before I give away my way? Well, let's see it. Let's try it. I would like to be there. All right. Let's see this. And then let's think about the kind of plot as well, right? So I need that table for sure. It's table.read table. My data folder, Pokemon.csv. I'll call that Pokemon. So there's my table. Big long table, of course. It's very wide with a bunch of different columns. What do I care about? I want HP values and I want the type values. Those are all the things I really need for this question, right? So what are their names? We've got attack. HP is lowercase, cool. And then we need their type 1, which is, I forget it's over here. So it's type 1 and HP. So I can just select those. Pokemon.select. Give me their type 1. Give me their HP. And like for each Pokemon, now I have just those values, which is all I really need. All right. So that gives me back a new table. I could save that as another table, like, I don't know, P. Whatever is useful for me. I'll call it P. And I could have updated the Pokemon table again if I'm never going to use it again. There's that. And then I want to group, right? Take that P table with those values. I want to group by type 1. And you can do cool stuff. What I did before to draw a graph was I just grouped by that and got the counts. That's what I did last time, secretly. So that's kind of nice. And then, so if you don't want the counts, though, like there are apparently 72 bug Pokemon across all the different versions, I can group by their primary type, which I've done, and I can take the average HP, not like how many Pokemon were there. What is their average HP? So what's going to happen is, essentially, let's use list as an example. What happens when you group? It's generating it's combining all the bugs in the dark Pokemon and the dragon Pokemon. It's making a sequence, and here's the sequence more or less, of all of their HP values, because that was the other thing in the table. And then we can apply a function to that sequence. Like list just gives you back the sequence. But np.average, we know, takes the average of a sequence of things. And so look at that. Look at those answers. It looks like some are better than like dragon, overpowered maybe, I don't know. We can take that, and that again produces a table which you can then maybe sort by HP, average, descending, equals true. Now you know that's like a named parameter. It looks like dragon really is the toughest, and then like normal for some interesting reason is the next toughest. But what kind of graph, once we have this now, what kind of graph would be the right one to display this data? What do we think? What are our options? Scatter, plot, bar H, histogram. Which of those? Would a scatter plot make sense? This one for sure wouldn't make sense because there's no chronology. I think bar is probably the right one because it's categorical, right? There's no like order. There's no order of the types. You can do alphabetical order, but it wouldn't make any sense. I don't think. And there's not many dots. It's like for one thing, it's like it's a size more or less. So I think a bar chart's the right one. If you wanted to keep the values separate, you could have maybe done a histogram of just like what are the HP values for every Pokemon for just a certain type. But once you like grouped by the types, you've kind of like you've got a categorical variable in the mix there. It's like you kind of have to include that. So I think a bar chart would be the right one. So like I can take all of this. I could save this somewhere if I wanted to. Or I can just like, I know that immediately I can take a table and do bar H on it by the type 1 column. And the sorting is kind of nice so that you can kind of see it in this order. It's like those poor bug Pokemon, not very powerful, very soft, and easy to beat down, I guess. So now we know. Any questions about how I solved for that and figured it out? You see it? All right, we could do other things. It's kind of nice. But I think that's more or less what I wanted to say there. I think, there's one other thing before we go. I want to show you some interesting stuff that you could do. What else do we? Let me show you some more options maybe. Just like by default, let's see. We had these and their HP values. Well, let's just go back to the original Pokemon table. And let's just like show some examples of things you could use group for. Original Pokemon table, you could say Pokemon dot group just by the type 1. And then it'll get you the count of all of those, and you could what's it called? You could of course graph that, like how many bug Pokemon are there, how many things are there. You could do let's see. We did the mean of their HPs and we graphed that. We could also group by multiple things at once, which is kind of interesting. I guess let's go back to the cones table for that one. This is the last thing I want to show you about group. Is this actually in the documentation? That's a good question. This might be a secret thing that only you can know. It is, okay. You can say table.group, and you can give more than one column, actually. You can give an array of column names. And then it will take each combination of those, each unique combination of elements of those columns. And that, in words, probably does not make a lot of sense. Let me show that to you. All right, so you don't have to give just one column for your grouping. You can give an array of column names or indices. Let me show that to you. And so let's go back to our cones table. Very simple. You can say, I'd like to group the cones table not by just the flavor anymore. I'll make an array of things I want to group by. I want you to not group by just the flavor or just the color. I want you to group by both in that order. Look what happens there. What it will do, but again, by default, it's taking counts. What it will do is it's like, all right, you've chosen flavor and color to group by. It will go and find each unique combination of flavors and colors. So strawberry and pink, that is one unique combination, and there's 2 of those in our examples. There's 2 of those in the data set. Same with chocolate, right? Chocolate, there's a chocolate dark brown and a chocolate light brown. There's only one light brown chocolate, one of those. But there's 2 dark brown chocolates. See how it's grouping by both? Every unique combination of those columns that you're asking about. You see it? So you can get more fine-grained that way. Like, go and find every combination of those guys. Let's see here. Yeah, you can do it like that. You can then go and find, like, you can do stuff with those now. It's like, all right, group by that. The only other thing left is price, by the way. And so you can take, like, give me the cheapest thing for each flavor and color combination. What's the minimum price for, like, dark brown chocolate, light brown chocolate, pink strawberry, stuff like that. So you can, again, aggregate based on the values. Like, sometimes you have multiple, right? That's the whole point of grouping. See which ones you have and do something with those. Pick out one, take an average, stuff like that. All right? Any questions about that? Does that make a little bit of sense? Just like you can group by multiple columns, and it will just go and pick out all the unique combinations of those 2 or 3 or 4, however many you gave, values. Okay, that's pretty cool. One maybe last thing I want to show you is you can give sequences in a shorter form. That's going back to this, like I'm sweeping this under the rug. The idea of a list in Python is like it's like a prehistoric array almost. We tend not to use them, but like it does make some things faster. If you give an array or just any sequence to this function, it doesn't really care. Another way to make a sequence is to give a list in Python. Like this is a way to give an array in Python. You say make array. It's a lot of typing. Sometimes I'm lazy. To make a list in Python, which is a more or less equivalent to an array, we'll talk about this more. It's the square brackets, and you put things between them. So like this is making the list with flavor and color in it. That I don't really want to say too much more of, but you can treat it very similarly to an array, but it's not as cool, but it's less typing. So sometimes you'll see that in your assignments as well as me just getting lazy and typing it this way. But it made no difference. Still a sequence of things, still grouped by those. Okay? I think that's as fancy as I want to get for the day. Any questions about any of that? So we talked about quite a few things. The most important thing, of course, is how to make functions. We're going to use those forever. And I guess I just want you to get comfortable with that and study my examples for the day after you've done your assignments. So yeah, I think that's everything that I wanted to talk about. That's a good place to stop. There's more where that came from. We're not finished with these slides, but I think that's a good stopping point for the day. We're just about at an hour and a half, which is a good amount of time. Are there any last questions before I let you go off and work? All right.